Hey guys, in this tutorial we will learn ufunctions in NumPy. So let's start. What are ufunctions? Ufunctions stands for universal functions and they are NumPy functions that operate in the array object. Why use ufunctions? Ufunctions are used to implement vectorization in NumPy, which is very faster than iterating over elements. They also provide broadcasting and additional methods like reduce, accumulate, and etc. They are very helpful for computation. Ufunctions also take additional arguments like where for boolean array or condition, defining where the operations should take place, or dtype for defining the return type of elements, and out for output array where the return value should be copied. So, what is vectorization? Converting iterative statements into a vector-based operation is called vectorization. It's faster as modern CPUs are optimized for such operations. For example, add the elements of two lists. So, x is 1, 2, 3, and 4, and y is 4, 5, 6, and 7, and z is empty list. So, one way of doing it is to iterate over both of the lists and then sum each elements. For I and j in zip, without ufunc we can use Python's built-in zip method. X and y and z dot append I plus j and print z. Open the terminal and py app.py, run, and we have this result: 1 plus 4, 2 plus 5, and yeah. So NumPy has a ufunc for this called add, and that will produce the same result. So comment this, and z is np dot add, and x and y, run. So we have an error, import numpy as np dot add, run, and we have the same result. Hey guys, in this part we talk about create function. How to create your own ufunc. To create your own ufunc, you have to define a function like you do with normal functions in Python. Then you add it to your NumPy ufunc library with the from pyfunc method. The from pyfunc method takes the following arguments: function is the name of the function, and inputs is the number of input arguments, and outputs is the number of output arrays. So for example, define my add, and x and y are inputs, and return x plus y, and my add is np dot from pyfunc, and send my add and 2 and 1, and print my add, and the first argument is 1, 2, 3, and 4, and second is 10, 11, and 12, and 30. Run, and we have this result. And check if a function is a ufunc. Check the type of a function to check if it's a ufunc or not. A ufunc should return numpy.ufunc. So print type of np.add method and comment these and run, and we have numpy.ufunc. And if it is not a ufunc, it will return another type, like this built-in numpy function for joining two or more arrays. Sorry, yeah, np.concatenate, and the type of np.concatenate is a function. And if the function is not recognized at all, it will return an error. So for example, np.blah blah and run, and we have an error in here. And to test if the function is a ufunc, in an if statement, use the numpy.ufunc value or np.ufunc if you use np as an alias for numpy. So comment this, and if type np.add is np.ufunc, print add is ufunc, and else print add is not ufunc. Run, and add is ufunc. Hey guys, in this part we talk about simple arithmetic in NumPy. Simple arithmetic. You could use arithmetic operators directly between NumPy arrays, but this section discusses an extension of the same where we have functions that can take any array like objects, for example lists, tuples, and etc., and perform arithmetic conditionally. Arithmetic conditionally means that we can define conditions where the arithmetic operation should happen. All of the discussed arithmetic functions take a where parameter in which we can specify that condition. So, addition: the add function sums the content of two arrays and return the results in a new array. So, array 1 is np.array, and 10, 11, 12, 30, 40, and 50. Copy and paste. And array 2 is 20, 21, 22, 23, and 24, and 25. And so print np.add array 1 and array 2 and run, and we have this result: 10 plus 12, 20, 11 plus 21, and etc. And subtraction: the subtraction function subtracts the value from one array with the values from another array and return the results in a new array. So copy and paste and np.subtract and run, and we have this result. And 10 minus 20 is minus 10, and etc. So change array 1 and array 2, run again, and we have this result. So I change the values. For example, 29, run again, and we have this result. And multiplication. The multiply function multiplies the values from one array with the values from another array and return the results in a new array. So print np dot multiply array1 and array2, run, and we have this result. And division. The divide function divides the values from one array with the values from another array and return the results in a new array. Copy and paste and divide, run, and we have this result. So array2 and array1, run again, 2, this and this, and these values. Change 29 to 30 or 45, run, and we have 3. And power. The power function raises the values from the first array to the power of the values of the second array and return the results in a new array. So np dot power and array1, array2, run, and we have these values. And reminder. Both the mod and the reminder functions return the remainder of the value in the first array corresponding to the values in the second array and return the results in a new array. Comment and print. So change the values to 3, 7, 9, 8, 2 and 33, and change values to 10, 20 and 30, 40, 50 and 60. And np dot mod array1 and array2, run, and we have this result. And you get the same result when using the reminder function. Copy and paste and reminder, run again, and we have the same result. And quotation and mod. The div mod function return both the quotation and the mod. The return value is 2 arrays. The first array contains the quotation and second array contains the mod. So comment and comment, copy and paste, print div mod and run, and we have this result. The first array represents the quotation or the integer value when you divide 10 with 3, 20 with 7 and 30 with 9, and etc. And the second array represents the remainders of the same divisions. And absolute values. Both the absolute and the abs functions do the same absolute operation element wise, but we should use absolute to avoid confusion with Python's inbuilt math.apps. So comment and copy paste np.absolute array1 or array, create another sorry, and 1 minus 2 3 minus 4 and run, and we have this result. Hey guys, in this part we talk about rounding decimals. Rounding decimals. There are primarily 5 ways in rounding of decimals in NumPy: truncation, fix, rounding, floor, and sale. So truncation. Remove the decimals and return the float number closest to 0. Use the trunc and fix functions. So array is np.array and minus 3.1666 and 3.66 and 7. Print array, and in here np.trunc. Run, and we have this result. And for example, fix, sorry, copy and paste, fix, and we have the same result. And rounding. The round function increments preceding digit or decimal by 1 if greater or equal to 5, else do nothing. For example, round off to 1 decimal point. This number without this, sorry, is 3.2. So round off this number and to 2 decimal places. Run, and we have 3.17. And floor. The floor function rounds off decimal to nearest lower integer. For example, floor of this number is 3. So array is np.floor and minus 3 dot this and 3 and this, sorry, dot. Run, and minus 4 and 3. And sale. The sale function rounds off decimal to nearest upper integer. So copy and paste and sale. Run, and minus 3 and 4. Hey guys, in this part we talk about NumPy likes. NumPy provides functions to perform like at the base 2, e, and 10. We will also explore how we can take like for any base by creating a custom ufunc. All of the like functions will place in minus in for infin elements if the like cannot be computed. Infinity. And like at base 2. Use the like2 function to perform like at the base 2. So array is np.range 1 and 10. So print the array, and sorry, we have this array, and print np.like2 in array. Run, and we have this result. And like at base 10. Use the like10 function to perform like at the base 10. Copy and paste and 10. Run, and we have this result. And natural like or like at base e. Use the like function to perform like at the base e. and like, run, and we have this result. And log at any base. NumPy doesn't provide any function to take log at any base, so we can use a FromPy function along with inbuilt function math.log with 2 input parameters and 1 output parameter. So in here, from math import log, and in here nplog is np.frompy func and send log 2 and 1, and in here nplog 150, run, and we have this result. For example, 8 and 2, and we have 3. Hey guys, in this part we talk about NumPy summations. What is difference between summation and addition? Addition is done between 2 arguments, whereas summation happens over n elements. So array1 is np.array 1, 2 and 3, copy and paste, and array2, and new array is np.add array1 array2 print new array, run, and we have this result. And some of the values in array1 and the values in array2. New array is np dot sum array1 array2, run, and we have 12, 6 and 6. And summation over an axis. If you specify axis 1, NumPy will sum the numbers in each array. So in here, set axis to 1, run, and we have 6 and 6. And cumulative sum. Cumulative sum means partially adding in elements in array. So in here, new array is np.com sum and send array1 and run 1, 3 and 6. We have 1, and 1 plus 2 is 3, and 3 plus 3 is 6. 3 plus 3. Hey guys, in this part we talk about NumPy products. To find the product of elements in an array, use the prod function. So array is np.array 1, 2, 3 and 4, and x is np.prod array and print x, run, and we have this result. So 1 by 2 and 3 and 4 is 24, and for example I create another array, so copy and paste, and 5 to 8, and np.prod array and array2, run, and we have this result by 5, 6, 7 and 8 is this is this result. and product around axis. If you specify axis 1, NumPy will return the product of each array. Set the axis to 1 and result 24 and this value. And cumulative product. Cumulative product means taking the product partially. Perform partial sum with the comprat function. So in here print np.comprat comprat and array, save and run, and we have this result. 1 by 2 is 2, 2 by 3 is 6, and 6 by 4 is 6, and 4 is 24. Hey guys, in this part we talk about differences in NumPy. A discrete difference means subtracting two successive elements. So for example, this array, the discrete difference would be 2 minus 1 and 3 minus 2 and 4 minus 3, and will be 1 and 1 and 1 and 1. To find the discrete difference, use a diff function. So array is np.array 1, 2, 3 and 4, and print array np.diff array, run. So py app.py, and we have 1, 1 and 1, and we can perform this operation repeatedly by giving parameter n. So for example, we have this, and the discrete difference with n equal to 2 would be this, and then since n equal to 2, we will do it once more with a new result. So the new result is 1 minus 1 and 1 minus 1, and will be 0 and 0. So compute discrete difference of the following array twice, and n equal to 2. Remove this and in here. Alright, and n is 2. Run, and we have this result. So for example, I change the array to 10, 50, 20 and 25, and 5, and run, and we have this result. Hey guys, in this part we talk about finding LCM, or lowest common multiple. The lowest common multiple is the smallest number that is a common multiple of two numbers. So find the LCM of the following two numbers. X equal to np.lcm and 4 and 6, and print x, run, and we have 12 because that is the lowest common multiple of both numbers. So 4 and 3 equal to 12, and 6 and 2 equal to 12. And finding LCM in arrays. To find the lowest common multiple of all values in an array, you can use the radius method. The radius method will use the ufunc. In this case, the LCM function on each element and reduce the array by one dimension. So in here, x is np dot LCM, and so in here np dot array 3, 6, and 9, and we should have 18. So what's the error? np dot LCM, so comment this and run again. So yeah, use the radius and run, and we have 18. And find the LCM of all values of an array where the array contains an integers from 1 to 10. In here, x is np dot LCM with radius and np dot arrange and 1 to 10. Run, and we have this number. Hey guys, in this part we talk about finding GCD, or greatest common denominator. The GCD, or greatest common denominator, also known as HCF or highest common factor, is the biggest number that is a common factor of both of the numbers. So find the HCF of the following two numbers. Print np dot GCD and 6, 9, and we should have 3 because that is the highest number. Both numbers can be divided by. So 6 divided by 3 is 2, and 9 divided by 3 is 3. Sorry, in here 6 divided by 2 is 3. Or no, I'm sorry, 6 divided by 3 is 2. And finding GCD in arrays. To find the highest common factor of all values in an array, you can use the radius method. So in here, print np dot GCD dot radius and send np dot array and 28, 32, 36, and 16. Run, and we have 4 because that is the highest number of all values can be divided by. Hey guys, in this part we talk about trigonometric functions in NumPy. NumPy provides the few functions sinus, cosinus, and tangent that take values in radians and produce the corresponding sinus, cosinus, and tangent values. So find sinus value of pi, divide by 2. X is np dot sin method and np dot pi divide by 2. Print x, and we should have 1, and we have 1. And find sin values for all the values in array. So in here, comment this, x is np dot sin and send np dot array and we have np dot pi divide by 2 and divide by 3, 4 and 5 and run, and we have 1, this and this. And if I add another 0, sinus of 0 is 0. Run, and we have 0 in here. And convert degrees into radians. By default, all of the trigonometric functions take radians as parameters, but you can convert radians to degrees and vice versa as well in NumPy. Note, radians values are this pi, so comment pi divide by this and zaptar and multiply by degree values. So in here copy and paste, and so comment this, and x is np dot degree to radian, and send an array 90, this 270 and 360. Run, and we have these radians. And radians to degrees. Convert all of the values in following array to degrees. In here, comment this and np dot radian to degree and run, and we have these values. And finding angles from values of sine, cosinus and tangent. For example, sine, cosinus and tangent, inverse, arcsine, arccos and arctan. NumPy provides ufunc, arcsine, arccos and arctan that produce radian values for corresponding sine, cos and tan values given. So in here, comment this, and x is np dot arcsine and 1. Run, and we have this value and angles of each value in arrays. So x is np dot arcsine and np dot array 1, -1 and 0.1. Run, and we have an error. np dot arcsine, in here we have an error. Run, and we have these values. And hypotenuse. Finding hypotenuse using Pythagoras theorem in NumPy. NumPy provides the hypot function that takes the base and perpendicular values and produces hypotenuse based on Pythagoras theorem. So in here we have base is 3 and perp is 4. X is np dot hypot and send base and perp. Run, and we have 5. Hey guys, in this part we talk about set operations. What is a set? A set in mathematics is a collection of unique elements. Sets are are used for operations involving frequent intersection, union, and difference operations. So create sets in NumPy. You can use NumPy's unique method to find unique elements from any array. For example, create a set array, but remember that the set arrays should only be 1D arrays. So in here, array is np.array and 1, 1, 1, and 1, and 2, and 3, and 4, 5, 5, and 6, and 7. And x is np.unique and array, and print x. Run, and we have this set. And finding union. To find the unique values of two arrays, use the union 1D method. So x is np.union 1D array 1 array 2. So array 1 is np.array 1, 2, 3, and 4, and array 2 is 3, 4, 5, and 6. And run, and we have this value. And finding intersection. To find only the values that are present in both arrays, use the intersect 1D method. Copy and paste and intersect 1D array 1 and array 2, and assume unique is true. Run, and we have 3 and 4. 3 and 4. And note, the intersect 1D method takes an optional argument, assume are unique, which if set to true can speed up computation. It should always be set to true when dealing with sets. And finding difference. To find only the values in first set that is not present in the second set, use the setDiff 1D method. X is np.set diff 1D, copy and paste and run, and we have 1 and 2. 1 and 2 are not in array 2. And finding symmetric difference. To find only the values that are not present in both sets, use the setXOR 1D method. X is np.set x or 1D and paste and run, and we have 1, 2, 5, and 6.